Do you also absolutely love how the Fallout 3 Nuka Cola vending machine looks? Well, I do, and that is why I built a prop version of it and then gave one to our pet pigeon Sophie. This video is sponsored by JLC PCB. More about them later in the video. Hi there! Some of you might think, why the heck did you make it a multi-part print and not just a single print model and just paint it? Well, don't worry, because while I did design this multi-part version so you can print each part in the correct color and don't have to use paint at all, I also designed this single body version which you can actually paint as you like. But more about that one later on. The reason I've designed this one to be paint free, so to speak, is that it is part of a much bigger project which I will of course also post when it's done. But that is a project for our pet pigeon Sophie, and due to that I can't use any paints because it is of course not safe to use paints on projects intended for animals. And if you want to see the big project I just mentioned, then make sure to subscribe so you won't miss it. Do note that the model you are seeing here doesn't have the detailed Nuka Cola machine backside. This is because this one is intended to be screwed against the wooden board, which will make much more sense when you have seen the large project I'm working on. You can however use this one as display piece perfectly fine though. The solid version does however have the detailed backside. When printing the multicolor multi-part version, you will need several different PLA colors. You will need red, white, a silver-like color like this. I would recommend to get one with a slightly metallic shine to it for the best results, dark green and transparent. I've used transparent PLA, you can also use transparent PETG or even just cut out the window from a spare piece of transparent plastic. I would recommend to print the actual logo in two colors by swapping filament mid-print. If you don't know how to do this, then make sure to check out this video, which I have linked and timestamped in the description below. Depending on what type of print you use, the filament and print speed, you might want to sand the parts a bit to remove the gloss. I've used the Creality CR10 SE at full speed for these parts, which is around 500 to 600 mm a second. And that will cause some surface inconsistencies as you can see here. This is because the slicer will adapt print speed here and there to optimize for details. Next, I also messed up this white part by accidentally breaking the thin part at the top. This is almost inevitable because it is a very fragile part, but we can just safely glue this because our pigeon won't be able to reach the glue at all once that's cured. When sanding the parts, either to remove the gloss or to minimize the printing lines, I would recommend to start with a larger grit like 50 and then work your way up to a finer grit of around 800. Also make sure that you sand in a rotating motion when you are starting to see results to minimize visible scratches. Next, I needed to make the tunnel of the screws a bit bigger in the red part because I somehow misplaced my regular Torx screwdriver and the alternative one I'm using now, which uses bits, doesn't fit. Don't worry though, I've made sure that the uploaded model won't have this issue because I've included bigger holes for the screwdriver in the published model. Now that's all out of the way, we'll start assembling the model. First we'll take the green block and push it all the way into the top of this grey part. Do note that the shadows might appear a bit differently depending on the print lines, which means you might need to rotate the green block for the desired effect. Now we'll take this block, which represents the coin slot of the machine, just slide it into the back of the red part and then if needed gently tap it in there with a hammer. And we'll do the same for the silver inlay in the door. Do however make sure that you have removed all the supports in the red part properly and that you have sanded the grey parts decently, otherwise you might crack the red part when hammering in these parts. And make sure to hit it in the middle and not at the top like I did, because you'll hammer it in screwed and then you're screwed. No worries though, this won't be noticeable in the end result. Then I welded the silver grey parts with the red part using my soldering iron set to 195 degrees Celsius, while using a tip on my soldering iron I exclusively use for this purpose. Next we'll take the small silver grey block and put it in the red block. Do make sure that the rounded corner is on the top right side though. Then take the small silver strip and insert it behind the block you just installed to keep it in place. Yes, I could have made it as one single part. I don't know anymore why I did it like this though, but I just left it as it is. Then I welded the silver parts together with the red body again. Then I pressed the white part on top of the red part, after which I created scratches in both sides of the silver top part. and also on the inside of the thin white side plates. This will ensure a much better adhesion for the glue later on. After I applied glue to both sides, I used the glue clamp and left it curing for a while to ensure that all parts were aligned perfectly. The glue I'm using is a very cheap one of just about 60 cents per pack for 3 tubes, but for me this one actually works better with PLA than the more expensive brands for some reason. Now we'll have to install the vents on the side of the vending machine. There is a short vent and a longer vent. The short one goes on the left side of the vending machine and the longer one goes on the right side. Do be careful when pushing them into the vending machine, because they might cause the thin white side parts to crack again if you didn't clean the edges of the hole enough or if you hadn't aligned it properly. This also happened with one of the sides on my vending machine, but this was easily fixed with a soldering iron again. Now it's time to screw the silver, the white and the red block all together with 2 screws. The model is designed to take 2 screws for this with a length of 60 mm and a diameter of 4 mm. These screws will go all the way through the entire model and hold all 3 parts strongly together. If you want to minimize seams between the parts due to the screw pushing the parts up while screwing it in, you could use a glue clamp to keep the parts tighter together while screwing in the screws. And as you can see, it already starts to look very familiar. However, we're not done yet. We still need to install the white bottom, or foot if you like, of the vending machine. The foot should be aligned flat with the back side of the vending machine, so it will look like this when installed. To install the foot, we're yet again using 2 screws, but this time we're using shorter screws which are just 30 mm long and have a diameter of 3 mm. Next we'll take our window and insert it into the back of the top part, followed by the dual color logo plate. We'll then insert the light box to see if we would need to sand it down a bit to get it flush with the back of the vending machine. I have on purpose made it with a very tight tolerance, so that you could use a very thin piece of plastic for the window, or so that you can just sand it down a bit by using a thicker piece. My light box is a bit too long due to that, so I sanded it down a bit until it had a perfect fit. To make the light box actually work, I've used this 3V LED filament and the 68 ohms resistor. I've put the LED filament inside the mount I've designed and then soldered one lead of the resistor to the positive lead of the LED filament. The positive lead of these LEDs is often indicated with a small hole in the metal lead. You could however also test this with a current limited power supply or in series with a resistor. Next I've soldered a piece of wire to the other lead of the LED and one onto the free lead of the resistor. Then I gently twisted the wire a couple of times to make sure that it would keep the LED in place inside the mount. Do be careful though that you don't use too much force when doing so, because these LED filaments are quite fragile and will break easily. Then with a bit of force, I installed the LED mount into the light box itself by pushing it in with pliers. Again, be careful when doing so, after which I fed the wire which I soldered onto the LED through the remaining hole of the light box. And after hooking it up to test if it all worked, I applied some hot glue to keep the wires in place inside the light box. Now it's time to push the light box into the back of the vending machine. If you're planning to use my drill stencil to mount it against the wall for example, then do make sure that the wire is coming out on the right side as shown here, otherwise the holes won't align. Obviously you also need to make sure that your window and logo are already installed before pushing the light box into the vending machine. To finalize the model, I used the soldering iron again to weld all the parts permanently in place while using as minimal glue as possible. This is of course optional for you, but I wanted to make sure that nothing can come loose because of the safety of our pigeon. I also welded the thin white sides on the front and top of the vending machine. I would however recommend not doing this if this is your first time using this technique, because it can become quite noticeable if done incorrectly. Well, this one is done now, and because this one is actually going to be hooked up to a larger control board which is intended for the big project I've mentioned earlier, which I obviously can't show you yet, I've decided to also make a smaller and simpler schematic using an ATtiny 85 microcontroller. I will be using my own XNL Lab Uno Overkill edition in combination with my ISP speed flash board to flash the ATtiny with the firmware for the light animation. And that also brings me to the sponsor of this video, JLC PCB. I have been using JLC PCB exclusively for about 6 to 7 years now. And as you can imagine, I was quite thrilled when they offered me to sponsor my projects. JLC PCB produces high quality PCBs for a very low price, starting at $2 for 1 to 8 layer PCBs. The average cost for me per 5 to 10 boards is about $4 to $5 for 2 layer PCBs, which is just a bargain if you would ask me. Everything is produced in-house at JLC PCB, which guarantees a consistent quality for both prototypes and large orders. Ordering from JLC PCB is also extremely simple. Let's say that you would want to order my XNL Lab Uno Overkill Edition, my ISP Speed Flash board and the XNL View Technologies Protoboard, which I will be using in this video. Then all you have to do is go to my website, add all 3 boards to your download basket, then proceed to the download checkout, where you can download them for free. You do not need to make an account to download from my website, by the way. After downloading the 3 boards, unzip these files and just go to the JLC PCB website. Drop the zip file, which I already prepared for use with JLC PCB, onto the website here. Select the quantity you want, in which color you want the board, and make sure to select the order number specified position if you are using my JLC PCB prepared zip files, so that the factory production number will be put in a neat predefined location. Repeat this process for the other 2 boards. Don't worry if the preview of your board or a downloaded board looks strange in the initial preview like you see here, because this is just a simple pre-render, and by clicking on Gerber Viewer you can see a 3D rendered preview of your board. And if you are still not sure if everything is well, then rest assured, because JLC PCB doesn't only have high quality PCBs, they also have an excellent customer service which you can easily reach via live chat, where they will answer all questions you might have in regards to your order. Do know though that this preview fail doesn't happen that often for me, and mostly only happens when I upload one of my older projects or when I have used an older version of Eagle, for example. But because some of my projects on my website are in a bit older format, I did want to include this information in here. And as you can see here, it will only cost me about $27 to get 20 custom PCBs shipped to my house, which will for me on average arrive in about 8 days. So if you want to order one of my boards or even one of your own designs, then I would definitely recommend checking out JLC PCB by clicking on the link in the description below or any of the links on my website. And of course, thank you to JLC PCB for sponsoring this video. No worries if you don't have these boards, because I've also included a link in the description to my blog on how to flash the ATtiny with a regular Arduino Uno. And the same instructions are also included in the download of the vending machine project as PDF, as well as the firmware you will need to get the correct animation and the schematics of this project. So using these 2 boards and Visual Micro as my Arduino IDE, I flashed the firmware onto the ATtiny 85. Then I plugged the ATtiny in my breadboard to confirm that everything looks as I want it to look. The circuit itself is actually quite simple. On pin 1, which is the reset pin, we have a 10K pull-up resistor. The ground is connected to pin 4. VCC or the positive lead is connected to pin 8. A 1K resistor on pin 5, which goes to the middle pin or base pin of this BC547 NPN transistor. And from this transistor we have a 68 ohms current limiting resistor going to the LED filament, with the other pin of the transistor being tied to ground and the remaining lead of the LED filament being tied to VCC. In the final circuit I will also be using 2 capacitors to ensure stable operation of the ATtiny. These are however currently not on the breadboard. Don't worry if this all went a bit too fast for you, because like mentioned earlier, you can also find the entire schematic in the PDF, which is included in the download. After comparing the animation with the in-game vending machine, I decided to modify the code a bit to make it look a bit more like the original one, only with slightly longer intervals between the blinking. After which it was time to put everything on a Protoboard so I could install it into the vending machine. I decided not to include this entire process in the video, because there are of course already plenty of videos on YouTube showing how to make your own boards like this. If you would however like me to make a tutorial in the future on how to make your own circuits on a Protoboard like this, then of course just let me know in the comments below. For now, I will just time-lapse the process a bit to save you some time. I do however want to mention that I created small standoffs from cut-off resistor leads for the LED filament to minimize possible shadows from the components on the PCB. Also make sure that when you are trying to align your LED filament after you've soldered it onto the leads, that you don't put any pressure on the LED filament itself. Because as demonstrated here, they can and will break very easily, which will render them useless. Once the circuit was done, I took a long wire, fed it through the Lightbox and soldered it onto the PCB. After which I glued the PCB into the Lightbox with hot glue. Do however yet again be careful not to break your LED filament when doing this, and that you don't melt or deform your Lightbox if you're using hot glue. Like mentioned in the beginning of the video, I have also created this solid body version of the vending machine, which you could paint yourself. And this will also be the one in which I will be installing my Lightbox. Because my channel isn't about miniature model painting, and because I'm far from being an expert at it, I won't show the whole process of how I've painted mine, but just do a fast time lapse again. I do have to mention that I didn't completely finish mine yet during the filming of this video, because it turned out that some of the paints I wanted to use were dried out. So unfortunately, I will still have to add quite a few additional effects and details after I have finished the video. But considering that this one isn't the main subject of the video, but just is an extra model I've created so others can download it and paint it for themselves, it doesn't really matter. I did by the way also sand this model a bit to lower the visibility of the printing lines. I already added some rust and aging effects to it, and I'm also planning to add some more details in the future, like oxidized spots, grease and dirt here and there, and for example shadows with black wash, etc. But like I've mentioned earlier, I will unfortunately have to wait until the new supplies have arrived to do so. I might do a community post in the future with some pictures once it's done, but that all depends on how busy I am with the other projects I have planned for you guys. After I painted most of my model, I installed the Lightbox into the back of the vending machine, just like I did with the multi-part version. However, the big difference between the Lightboxes of both vending machines is that this one actually has all the control electronics built into it. And you could of course do the same for the multi-part version if you would like to. And this is the result of both vending machines, where the clean one on the left is being controlled with an external main board, which will be revealed in a future video, and where the post-war version, so to speak, is controlled by its own internal circuit. I do have to admit that even though I'm not finished painting the one on the right yet, I'm already quite pleased with the results, to be honest. I also absolutely love how the light sequence turned out in these vending machines. Unfortunately, the actual effect of the light is of course difficult to show on camera, but it honestly looks much better than I initially expected. You can see it a bit better when I turn off the studio lights, but I can assure you that the camera absolutely doesn't do justice to this project. Here's some additional footage from my iPhone in very low light conditions. I really like how they give off that Fallout vibe in the dark. You can find all the files needed to make this project in the link in the description below. If you have built Sophie's Nuka Cola Vending Machine, then don't forget to post it on either X or Instagram and tag me in your post. I will then repost the first couple of submissions. Thank you for watching. Leave a thumbs up if you liked the video. And don't forget to subscribe if you'd like to see more content like this.